In this video, we're going to look at gas-forming reactions, which is a type of acid-base reaction. In a gas-forming reaction, one reactant is a base that contains the carbonate ion or the bicarbonate ion. Stop the video and figure out what is the other reactant. And the answer is an acid. Baking soda contains the bicarbonate ion. This compound will react with an acid to form a gas. Since acids and bases are often solutions, we can use concentration to quantify the amount of acid or base in the solution. You often know the concentration and molarity and the volume of an acid or base. So for a solution, you can use this equation to calculate moles. These equations describe pH, pOH, and how those two quantities are related. A gas-forming reaction is a type of acid-base reaction, so stop the video, read these three statements here, then fill in the blanks. And the answers are, and for the net ionic equation, the bicarbonate base reacts with H plus acid to produce water and CO2 gas. Remember, if you can write a net ionic equation, you can predict that the reaction occurs. So stop the video and see if you can write a net ionic equation for this reaction. And the answer is, replace H2CO3 with H2O and CO2 gas. Next, write your net ionic equation. You ate too much and have indigestion. You know, Alka-Seltzer and milk of magnesia are two very common antacids. Stop the video and figure out which antacid will make you burp. And the answer is, Alka-Seltzer is baking soda. The acid in your stomach is hydrochloric acid. Remember, when H2CO3 forms as a product, replace that with H2O and CO2. So Alka-Seltzer will make you burp. What about milk of magnesia? No gas is formed, so milk of magnesia will not make you burp. Here are two more gas-forming reactions. When a sulfide compound reacts with an acid, H2S gas is formed. That's the rotten egg odor. When a cyanide compound reacts with acid, HCN gas is formed. This reaction was involved in the Chicago Tylenol murders in 1982. Look it up. Let's practice another reaction. Washing soda is sodium carbonate. Stop the video and predict whether washing soda reacts with battery acid. And the answer is, our ionic equation looks like. So we predict that washing soda will react with battery acid. Here are the tools in your chemistry toolbox so far. By practicing these problems, you'll know which tool to use when you're solving problems. So stop the video and review these tools. Here's a good practice problem. You're doing a chemistry demonstration. You add a white solid to water, the solid disappears and the water turns pink. Then you pour a colorless liquid into the pink liquid, you put a rubber stopper in the flask, shake the flask, and then the stopper flies through the air. The liquid stays pink. Here's what your audience sees. So you add the white solid to water, water turns pink. You add a colorless liquid to the pink one, put a stopper on, after a few seconds the stopper pops off. That's why you wear your safety glasses. And the liquid stays pink. Ignore this other stuff. Let's review limiting and excess reactants. Remember, the coefficients in the balanced chemical equation tell us the number or the moles of each reactant and product. So stop the video and answer these two questions. And the answer is 5.5 bodies. Those 11 arms give us the smallest or limits the number of bodies produced. So arms is the limiting reactant. Here are the answers. Laundry detergent is the solid. Laundry detergent is the only base of these three solids. The water turned pink because a drop of phenolphthalein was added. For B, the colorless liquid is HCl. HCl is a strong acid and reacts with a sodium carbonate base. CO2 gas is produced and pops the stopper off the flask. For part C, remember, phenolphthalein is colorless and acid, pink in base. Since the liquid stays pink, the excess reactant is the base and the limiting reactant is the acid. See the next slide. 8 grams of sodium carbonate gives us 0.075 moles. 100 mils of 1 mole of HCl gives us 0.1 moles. Which one limits the amount of product produced? HCl. What gas-forming reaction makes my pancakes fluffy? It's the double-acting baking powder. We know baking soda reacts with acid to form CO2. The acid comes from the alum when water is added to make the pancake batter. That's the first act. Here's the second act. When monocalcium phosphate is heated, when you put your pancake batter on your frying pan, acid is produced. So there's two ways to make acid, in double-acting baking powder, and there's enough baking soda to react with all that acid to produce the CO2 to make your fluffy pancakes. An acid-base titration is a very common experiment to quantitatively measure the concentration of an acid or base. Any experiment takes planning. Here's a few for an acid-base titration. Stop the video and answer these questions. And the answers are, for the last one, the base usually goes in the burette. Base is added to the acid in the beaker until the solution turns pink. At this point, all of the acid has been neutralized by the base. The vinegar label states 5% acid, but you want to do an experiment to confirm the acidity. Here are a few questions you can ask as you plan your experiment. Let's do an example. Here are data collected in an acid-base titration. Stop the video and determine the concentration of HCl. And the answer is, here's how we got that answer. First, balance the equation. Next, check the information you're given. So you have the information to calculate the moles of NaOH, but not the moles of HCl. Next, from the moles of NaOH, you can calculate the moles of HCl from the balanced chemical equation. Finally, calculate the concentration of HCl from the moles and the volume. Here's another experiment. Stop the video and figure out how would you determine how much acid is in soda. The answer is essentially the same way you figure out how much acid is in vinegar. Substitute the soda for the vinegar and titrate the soda with a base. We mentioned in an earlier video how the acid, say in soda, can dissolve the enamel in your teeth. Can the acid in Mountain Dew dissolve a mouse? Stop the video and find out.